We're going to begin this chapter here with something that should be pretty natural and understandable and really familiar, but even if it's not, the idea of looking at a percentage should be pretty well natural and understandable as an extension on our base 10 number system. Whether we're trying to describe something like your score on the first exam, or how tall and heavy you might be relative to your peers, or how effective the best defenders and scorers are in your favorite sports, the idea of being able to describe a value out of 100 makes, well, sense in a number system built around powers of 10. And in particular, the etymology of the word percent kind of tells us exactly what it does. It's one of those nice things where it's exactly right there, that when we're looking at percents, we are literally looking for values out of 100 parts. So something like a percentage of 79 says we are taking 79 parts out of a possible 100, whether that's 79 goals scored out of 100 shots, or 79 points out of the 100 you could have gotten. Where the idea also of that symbol, the weird little slash with the bubbles around it, also comes from Italian, as they had in the 14th century used a P with an accent next to the number 100 that slowly, over the course of the next few hundred years, morphed into a P with a couple of zeros on a division type symbol until it became what we're a lot more familiar with today. Where, if you want to convert a value from a decimal or fraction to a percent, well, if you don't have a decimal, you just make your decimal by dividing, and then you move the symbol over, the decimal place over 2 digits to the right, that is, you multiply by 100, and add in your symbol to get the value. And hopefully you know how to do this, but just to be sure, we're going to take some quick examples going in that direction, and then we'll also later see an example going in the other direction. For our first example, we want to express the following as percents, where we have 12 over 16 and 0.319. Now in that first case, what you have to do there is, as I said, divide these values out. So we have 12 over 16, or if you really prefer, and some might, 3 over 4, and expressing that as a decimal, we would get 0.75, 75%, which occurs by multiplying by 100, sliding that decimal place over, and adding our symbol there, like so. Meanwhile, in the second case, we've already done the hard part of getting decimal. So if we have a value like 0.319, and you want to express that as percent, again, you just multiply by 100 and add the symbol, so we'd have 31.9%. These refer to the exact same value. It's just, well, we may want to express it as a percentage instead of a decimal, because it gives us a nicer, more dramatic picture. And for that matter, if we want to go the other way, if we have something like 220%, and we want to express that as a decimal, we can just pull the decimal place over back to the left, divide by 100, and this would be the value 2.2 as a decimal. Or if we have something like 62%, we could play the same sort of game, pull the decimal place over, and we have the decimal value 0.62 that represents the exact same thing, just in a different unit. Percentages are, they're a weird unit, but that's what they are. And then from here, now that we've reminded ourselves, hopefully, of the notation for percentages, we're going to get some practice actually using them, first looking at sales tax.